Hello everyone, welcome to this subscriber only YouTube live session on understanding packages and scopes, mastering packages and scopes. I'm sorry. This is our second session in a series of Golang expert sessions. Previously, we did a session on creating your first Go program like a professional. Building on that, in this second session, we are going to understand the concepts, basic concepts around packages and scopes in Golang. It is very important to thoroughly understand the concepts around packages and scopes in order to build robust Golang applications. By the end of this session, if you like this session, please hit the like button. Please share this with your friends, colleagues, acquaintances so that everybody can get a benefit of this. Please spread a word and ask people to subscribe to Golangda. These are going to be subscribers only sessions. Let's move ahead in order to achieve our goal today, mastering packages and scopes. In order to achieve our goal, we have to go through following milestones. First is understanding the concepts around packages, understanding the concepts around scopes, and finally, we will put the concepts we learn together in a Go application where we are making use of the concepts around packages and scopes we learned. Please keep posting your questions, queries, comments in the chat box. I will answer all of them towards the end of this session. Let's move ahead to our first milestone, understanding packages. I'm going to make a few statements around packages. You may not understand all of them right now, but be with me. Please be with me. We will go through an example afterwards, and then we will revisit the statements. You will probably understand all of them. If you don't, you can always come back to this video and rewatch it. A package is a group of source code files inside same directory. For example, package main inside gopath cmd directory. A package directory can contain multiple subdirectories and each subdirectory is a separate package. All files in the same parent directory belong to the same package. Packages help us write modular code. Let's see an example to understand this concept. Right now we are in a project called packages. This project has two directories. One is cmd, another is pkg, and there is one more file called go.mod. We have studied what go.mod contains and what's the significance of go.mod in our previous session, create your first Golang project like a pro. You can always go back and watch that video if you want to know more. Also, we in future we are going to have a detailed session about go.mod, what is its significance, what are the different options it provides for dependency management in Go. For now, let's get back to our packages project. Contains my function main. This is under package main. So it is advised that you keep your package main inside cmd directory. You can create multiple directories under cmd directories, but it is not advised. As I stated earlier, this directory or package, I'm going to say these names interchangeably because one directory denotes one package, have multiple files. One is hello.go and another is main.go. Let's see what hello.go contains. Hello.go contains a function called hello. It simply prints hello from package main. This file is also a part of package main. All the files under same parent directory or must belong to same package. I cannot include one file in main package and another file in some lib package. That is not allowed. If you want to create uh, another file with a different package under same CMD directory, you may have to create another directory under CMD, and you may have to add another file with another package name. Just like we have done, I will show you in pkg directory. So what my main function is doing, at first it is calling a hello function in same package main, which is written inside hello.go inside cmd directory, that is inside package main. Let's see what's there inside pkg directory. In pkg directory, we have one directory named lib and a file named hello.go. So a file named hello.go under pkg directory has a function called hello. Please observe the first letter of function hello is capital. There is a reason behind it. I will explain why we have kept it capital. If you see in main.go, the second statement I'm making is lib.hello, which is from within a lib package inside pkg directory, which also has another file hello.go. So right now in total we have three hello.go files. One is inside cmd directory, which belongs to package main. One is inside lib directory, which belongs to package lib. One is inside pkg directory, which belongs to package pkg. Please observe that lib directory as well as hello.go file are under same pkg directory, but a hello.go file under lib directory has a different package name than hello.go file under pkg directory. This is allowed. Now let's come back to main. What I'm doing here at line number 10, I'm making a call to hello function inside lib package. Let's see what is this function doing. This is again printing hello from package lib. How I get here? You have to hold a control key, hover over this hello function and click. This is possible because we enabled IntelliSense in my VS Code editor. How to do that? We have already explained it in our previous session, as well as a video which says uh, Golang VS Code setup for Windows, Golang VS Code setup for Linux. VS Code setup for Golang programming on Windows and on Linux is same. You can always go back to those videos and watch them to learn how to configure your VS Code editor. So, in summary, in my project packages, I have two directories, CMD and PKG. Under PKG directory, I have another directory called lib. Under CMD, I'm keeping all the files belonging to my package main. These two files are at the same level in the directory tree. That's why they cannot have a different package. Then inside pkg directory, I have one file called hello.go, which belongs to package pkg. Then I have another directory called lib. And inside that directory lib, I have another file hello.go, which belongs to package lib. This is allowed. When I run this, for convenience, I've already compiled this project in packages.exe. Let's run this now. Let's see what it prints. So if you go here, my first call is to hello function from the hello.go inside main package. So it says hello from package main. My second call is to hello function from lib package. If you observe the import statement, whenever I'm making use of some function from some package, this package gets imported here because our auto imports are enabled in my VS Code editor. If they are not enabled, you may have to manually type this statement. Coming back to third call inside my main function, pkg.hello is a call to function hello from directory pkg. That's why my third statement says hello from package pkg. So let's coming back to our statements about packages. Let's see if these statements can make sense to you right now. A package is a group of source code files inside the same directory. For example, package main inside gopath/cmd directory. A package directory can contain multiple subdirectories and each subdirectory is a separate package. All files in the same parent directory belong to the same package. Packages help us write modular code. What do you mean by modular code? We will see and understand what is the meaning of modular code when we see the final example in today's lecture. Our first milestone is complete. There are some concepts around packages I need to I want to tell you. We looked at three packages in this program. First is package main, second is package lib, and third is package pkg. So in Golang, a package which contains main function which has to be package main is called executable package because execution of every Golang application starts inside main and main function is always a part of package main. You can have only one main function inside package main. All other packages like this package pkg, package lib are called library packages. Library packages can be imported like this. You cannot and should not import main package inside library packages because it will create cyclic dependency and your program will never compile. So now that you understood what are library packages and what are executable packages, let's see few differences. Library packages are created for reuse. That means for importing in other programs. The functionalities we create inside library packages are meant to be used by other applications as and when needed. Executable package is created for execution. There can only be one executable package in any Go application, that is package main. Inside library package, there will be no function main. Inside executable package, it must contain function main. Library package can be imported. Main package should not be imported. It will crash your program. So this is about packages. Now we have achieved our first milestone. Let's go to our second milestone, understanding scopes. Let us observe this program. What I've done here, I have created a simple Go program with two functions in it. First is main, obviously because the Golang program execution start inside main. And second is INR. INR simply increments the value of I and then prints it. If you observe at line number 5, I have declared one variable called I equal to 3. Inside main function at line number 1, I have declared another variable called I equal to 9. At line number 9, I'm making a call to function INR. Obviously, at line number 9, the control goes to this function INR. It executes these statements and then comes back here. At line number 11, I have declared another variable called I equal to 11. And I have printed the value of I inside if block. At line number 14, I am again printing value of I. If you observe the output of this, I inside inc block is printing value 4. I inside if block is printing value 11. I inside main block is printing value 9. For a newcomer or newbie, this could be confusing. But this happens according to certain rules given by Golang. These are called scoping rules. What are scoping rules? We will study right after we study what are scopes and how the scopes are defined in Golang. So I'm going to make few more statements about the concepts around scopes. Let's be patient. We will see the example and come back and revisit these statements. The scope is nothing but the visibility of the declared names. The names could be variables, functions, or statements. When I say statement, a statement does not alter the control flow of a program. For example, import statement. Import FMT is a statement. An expression. So each program is consists of either statements or expressions. Expressions generally do alter the control of a program and return values. A equal to add 3 4, it's a function call. From name, it's obviously suggesting that it is going to return the sum of 3 and 4. This is an expression, this is a statement. So the statement about scopes here is the scope is nothing but the visibility of the declared names. The names could be variables, functions, or statements. The blocks in the code delimit the scope. This word blocks is very important. What are blocks? Blocks are denoted by curly braces, as there are some optional keywords, then there is opening curly brace. Inside that there are some statements or expressions, and then there is a closing curly brace. This structure, wherever you find this structure inside your code, this is going to demark your or delimit the scope inside your program. How? Let's see. If you see here, the I at line number 8 is a part of a block called main function block. How did we define block here? Block is delimited with opening curly brace. Before opening curly brace, there are some keywords, and then there is a closing curly brace, and nothing after that closing curly brace. So this I at line number 8 belongs to a block called main, because this main block starts here and ends at line number 15. Main block starts at line number 7, ends at line number 15. If you observe again, at line number 10, there is one more block is being created inside your program. This is if block. If block starts at line number 10 and ends at line number 13. That's why the I at line number 11 belongs to if block. Even though it's not a part of main block, it's a part of if block. The variable you declare inside a block has a scope within that block only. What does that mean? This I has a life inside this if block only. This I has a life inside entire main block. Similarly, at line number 17, we are creating another block with this opening curly brace, and before that there is a set of keywords, like it's declaring your function name. This is called INR block. The I inside this INR block is although it's different. This is not a initialization statement. This is just an assignment statement. I have what this statement is doing. This is not creating another variable with the name I. It is just incrementing the variable I, which I already declared at line number 5. How can this function INR access this variable I? Because this variable I is belongs to a scope called package scope. What is package scope? We will study in a while. So this I is not different than this I, but I at line number 8 is different from I at line number 5. I at line number 11 is different from I at line number 8 and I at line number 5. Remember this. So these blocks delimit the scope of the variables in a Golang program. Now, what are different types of scopes in Golang, and how do we identify which statement or which variable or which expression belongs to which scope? Let us understand. I hope you understood these concepts. Let's go back to our statements. The scope is nothing but the visibility of declared names. Names could be variables, functions, or statements. The blocks in the code delimit the scope. Blocks are denoted by curly braces or as like this. And right now we are able to identify the blocks in our program. Let us study or let us understand how to determine the scope of these variables inside different blocks. So there are different types of scopes in Golang. First type is block scope. Names, which could be variables or functions inside the block, are block scoped. They are visible only inside declared block. Like this I here. This is visible. This I here at line number 11 is visible inside only this if block. That's why scope of this I is limited to if block. This I is a block scoped variable. This I at line number 8 is again a block scoped variable. It belongs to a block called main. Package scope. Names, which could be variables or functions outside the block, visible inside entire package but not outside package. Let's see. There is a variable I at line number 5. This is not a part of any block. So what our definition of package scope says? Names which are outside the block. That's why this variable I is a package scoped variable. Package scoped variables are visible throughout the package. That means this I is visible throughout this main.go file as well as all the files which are present in the main package. That's why this function inr can access the value of I at line number 5. Third, global scoped. Package scoped names variables or functions with the first letter in capital. If you remember our previous example, there were functions inside lib and pkg which had their first letter in capital. Both the functions were named hello. So whenever we wanted to access a function from different package, we first need to export them or make them global scoped. We will see in a bit with our next example. Global scoped variables, names or functions, they are visible to all files in all packages in the project. Third, file scope. Names outside the block, these are usually statements visible only inside the file they are declared in. All import statements are file scoped. If you see this import fmt statement, this has only a file scope. What does file scope means? This fmt has visibility only inside this file main.go. If you want to use any function from fmt package in a different file in the same package, you will have to import it again. We will see in a bit. So I've just labeled all the variables in our Golang program. So at line number 3, this import fmt statement, this fmt is a file scope name. At line number 5, I is a package scoped variable. At line number 8, this I is a block scope variable which belongs to main block. At line number 11, this I is a block scope variable which belongs to block F. At line number 18, this I'm not initializing a new variable here. I'm just incrementing variable I and assigning the new value back to I, which was initialized at line number 5. That's why this is a package scope variable, although it is inside this block. So always remember, the first declaration of your variable decides scope of that variable, and also the location of your declaration decides the scope of that variable. Because I declare this variable I at line number 5, which is not with inside any block, this I automatically gets package scope. Because I declared this I at line number 8 inside main block, because of this location, it gets automatically the block scope which belongs to block main. This I at line number 11 automatically gets a block scope which belongs to this block if. I hope that has cleared concepts around scopes. So there are few rules of scoping. We already discussed them. I'm going to reiterate. Location of a statement or expression in a Go source code defines its scope within the program. We cannot redeclare a package scope variable, but we can redeclare a block scoped variable. We will see. Importing happens in the file scope. We just seen. Import statement is file scope by default. Now we have achieved our second milestone as well. Now let us put it all together and create a Go application which demonstrates the use of packages and scopes inside a Golang application. I have already created one application. I'm going to open it. So again, this application has two directories, CMD and PKG. Obviously, there are going to be different packages inside CMD and PKG directories. Let's see what's there inside CMD and what's inside PKG directory. Inside CMD directory, there is main.go where I have created a main function. I have also declared two package scoped numeric variables num1 and num2 with value 2 and 3. These variables, because of their location of declaration, gets automatically get package scope. What I'm doing inside main, first statement, I'm just printing a welcome message from main function. Then I'm calling a function named hello. If you see, first letter of this function is not capital. That means this function is not from outside this package. It's from the same package. Now, if you see this if you observe this function hello, it has a package scope. Why? Because it is not a part, it is not within the declaration of name hello is not within any block. Block starts here and ends here. We have declared function name outside the block. That's why automatically it gets the package scope. A package scoped variable, a package scope function is accessible from any file inside the same package. This file add and square it.go belongs to package main. That's why I can directly access function hello, which is written inside add and square it.go file from within main function without any extra effort. I can just call it by its name. Now there is another function I'm calling, which is called add and square. Now, just by looking at this function, you can tell this is a package scope function because I'm calling it from the file in which it is not declared, and first letter of this function is small. Come here. How did I get here? Hold control key, hover over the function name, click on it. It will your IntelliSense will take you to function definition. Now I have defined this function here. what this function is doing, it is adding two numbers, num1 and num2. Where are these numbers coming from? These are not declared inside this function, these are not declared inside this file. Where are these numbers coming from? Let's see. Hover over this number, hold control key, click on it, you will get back to the initial declaration of this variable. Num1 and num2 are declared inside a file called main.go. Because these variables are not inside any block, these are package scoped variables. Now, as its definition suggests, package scope variables are visible in all files inside the same package. So right now I can access num1 and num2. I'm calculating the sum and I am going to square the result using a function called square it, which is not written inside this main package. Where is it written? Just by looking at the function call, I can tell it's written inside a package called lib. Where this package lib is present, it is present in my same project, lives, packages and scopes, packages, pkg, lib. And now I want to go to the definition of this square it function. Also, just by looking at the name of this square it function, if you observe, first letter of this function is S. What does that signify? It signifies that this square it function has a global scope because we made it so explicitly by making its first letter capital. What I've written inside square it function, I'm making a call to a function called hello. This hello function it has first letter in small. That means this hello function must belong to the same package where this square it function is written. It's written inside lib package. So this hello function is also here. This is calling this hello function. I came here, I saw hello from package lib. This is again a package scope function. This function is a global scope function. Just by looking at its name, first letter is capital. That's why it's a global scope function. Now, coming back to my main. Okay, now at line number 8, what square it is doing? It is just returning the square of the number I'm passing to it. Which number I'm passing to it? I'm calling this square it function from add and square it.go file, which is in package main. I'm passing the sum of num1 and num2, which are package scope variables declared inside main.go. So this is how this packages and scoping is working in our Go application. I want you guys to observe one more thing here. If you see this import statement, why this import statement came into picture here? Because I am using one function println from fmt package. As soon as I use this function, my VS Code auto imported this fmt package. Now I have this file add and square it.go inside same main package. I'm using fmt.println here as well. But if you observe the import statements here, it is again importing this fmt here. Although it has already imported fmt here in main.go, which is in the same package, it is again importing fmt here. What does that mean? Import statement has only file scope. By default, all import statement has file scope. If you want to use any function from an imported package in any file, for inside each file you have to add import statement. So import statements are file scoped. Any variables or functions you declare outside block are package scoped. If you make their first letter capital, they became global scope. Now we studied package main is an executable package. We should not import package main in any other package. It creates problems. If you are not going to import package main in any other package, there is no point in making any variable or any function inside main global scoped. So please try to avoid from making any variable or any function inside main package global scoped. That what does that mean? Don't use capital letter while declaring any function or any variable inside your main package. It's not advised. You can do it, but it is not advised. Now let's run this application. Let's first compile. Packages and scopes dot exe cmd. I've compiled it. Let's run it. So here we go. We get at line number 13 what I'm printing, welcome from main function. Welcome from main function. At line number 14, I'm making a call to hello function in the same package. It says hello from package main. At line number 15, I'm calling add and square. It's what it is doing. It is adding these two numbers and then calling a function square it from lib package, which is just squaring it. Before squaring, it is just printing a hello message using hello function written inside the lib package. So this says hello from package lib and it prints the actual result at line number 13 in this particular file. So I was speaking about modularity. Packages and scopes help us keep our code modular. This is a very simple program. What I did here, I just I just outsourced the responsibility of squaring this number to a function called square it, which is not a part of main package. I have written it inside lib package, this function. Now, as I have made this function global scoped and have kept in a library package, any other package in my program can call this function using this lib package name. So I have achieved two things here. I have segregated the responsibilities of adding the number and then squaring the number in among two different functions. This function just adds and this function squares the result. And this code I have made reusable. This is called modularity. So packages and scopes help us creating modular and robust Go programs. Now we are aware of all the milestones in our quest of achieving our goal. So I can say that now you are the master of the packages and scopes in Golang. Thank you for being patient and listening to this live session. Let's see if there are any questions. Okay, I see there are no questions. So let's stop here for today. If there are any questions, you can always add those questions on comments, inside comments on this lecture. Let's meet in our next session. Thank you very much and good evening.